Okay, back at this. So I needed to put the total on the bottom. So to keep this 3/5, to say, oh, this is equal to this 3/5, we need to have males on top, 240 plus x over the total on bottom. So 160 plus 100 is 260. So this is 260 bats plus the 240 bats plus our unknown addition. So it got just a touch more complicated than we were ready for, but that's fine. We can sum this up and cross multiply. So we get 260 plus 240, of course, is 400, 500. So 240 plus x equals 3/5 times 500 plus x. Cool. 5 goes into 500, 100 times. And we get some output of 240 plus x equals 300 plus 3/5 x. Ah, looking great. Look at us. So subtract 3/5 x. Let me make some room. I'll come back over here. Just a long algebra problem, but not hard. Subtract 3/5 x, and you get 2/5 x, and we subtract 240 equals 60, right? So subtract 240, subtract 3/5 x, right? I rewrote that here. Multiply by the reciprocal, 5 halves, 5 halves. We get x equals 30 times 5, 5 times 3 is 150. So we would need to add 150 bats to keep that ratio, and that's correct. So yeah, it looks easy, but just tricky, keeping that in mind, all those little details. Now again, we're entering in quite difficult territory, so I will slow down here. Yeah, we're in dynamic fluid pressure. We don't want to touch these. You just want to kind of hop past these. Figure of Bose, and the radius 10, the length of the bark AB is in bold. Okay, is between 5 and 6. What is one possible integer value of x? Okay, we might be able to do this one. Let's slow down. The figure above, the circle has a center of O, okay, and a radius of 10. So R is 10, no big deal. And it says, if the arc of AB, shown in bold, is between 5 and 6, cool. So remember, we're talking arcs. The full circumference is 2 pi r. And if we know r is 10, the full circumference would be 2 pi times 10, which of course is 20 pi. Cool. So if we just half that, that would be 10 pi. 10 times 3 is somewhere around 30. If we halved it again, we would have somewhere around 15. So if this is 5 and 6, what is one possible integer value of x, that angle? How interesting. So what if we did this? Let's keep it more simple than that even. So what if we did x over 360 equals, and I'm just going to do proportion here. I'm just going to pick 5 or 6, just 5 for ease. 5 over, and remember, 2 pi times 10. Cool? And now solve for x. That's what I would do here. So x would equal, let's reduce this, 1, 2, so we get 1 over 4 pi times 360. So 4 goes into 360 how many times? 90 times. So we get some crazy value of 90 divided by pi. Whatever that is. What is 90 divided by about 3? Well, it's about 30. So I would guess something in there, 30. And that is correct. All right. So that was a good one to guess on. Go fast, just a simple proportion. And all right, I think this is going to tie things up. If we want to do a few more, we can, but some of these might be hard. What's the value What value should the analyst use for R? Okay, this is not too bad. Stock price of one share of a certain company is $360 today. So that means our principal value. Stock analyst believes that the stock will lose 28%. So R is going to be equal to 1 minus 0.28. That's how you would show R of its value each week for the next 3 weeks. So the analyst uses the equation V equals 360 times R to the T to model the value of V of the stock after T weeks. So we need to say, what should the analyst use for R? Well, 1 minus 0.28 would be R. But he wants to say, I think that's right actually, let's see. Yeah, 1 minus 0.28 is 0.72. Yeah, correct. This is 0.72. There you go. So that was a quick and easy one. Nothing hard about that at all. To the nearest dollar, what does the analyst believe the value of the stock will be at the end of the 3 weeks? And now we just multiply this out. 360 times 0.72 raised to the third power. Whatever that is. And that comes out to 134. Okay, that's its value. That would be it losing 28% over 3 weeks. So 28%, 28%, 28%. All right, and that's the last one. If you guys have any particular wants for the questions we skipped over, I'll come back and highlight those here. If you get to the end and you're like, oh, I'm interested, I am happy to do them. So just shoot me a message and I will happily write you back and solve all those problems. So just for reference, we stopped at somewhere around 21. Yeah, we stopped at 21 and all the way to 30. And we did a few in there, but 21 to 30, so that's like 9 problems. If you'd like to see more of those, just write me and let me know. I'm happy to solve them. If not, glad to help out. Hopefully this is a good launching pad to your practice and SATs. Good luck, and hope to see you guys at graduation.